Hello viewer and welcome to the e-learning classroom. So today we want to look at this setup that can be used to determine the resistivity of the wire we have here. So we have this setup, that is the setup we have. We have voltmeter here, ammeter, cells and switch, and then the setup is as we can see here. As we can see from the diagram, we have the cells here, switch and ammeter, cells, switch and ammeter, as you can see there. Then we have the nichrome in between, and then we have the voltmeter on the top end. So we have already done the connection. So we are trying to close the switch and then record the current and voltage readings. We are trying to close the switch and record the current and the voltage across the wire PQ, and then from there we'll determine the resistance. Then we'll determine the resistivity using the formula given down here. So the first thing, let's close the switch and record the voltmeter and ammeter readings. So we have closed the switch. For the voltmeter, we are using the upper scale. So these are 10, 20, 30, 32 divisions. So 32 times 0.05, that is 1.6 volts. 1.6 volts. Then for the ammeter, we are using the upper scale as well. That is 0.1. For the ammeter we have 0.1 stretch, 0.10 ampere. So we have the two values. So we can use now the two values to determine the resistivity. So viewers, now we can use these values to determine the resistivity of the nichrome wire we have here using the values we have obtained. So we first get the resistance, V over I. So that means resistance will be 1.6 divided by 0.10, and that means we have 1.6 divided by 0.10, that is 16 ohm. 16 ohm, that is the resistance of that nichrome wire. Then from there as well, we are trying to measure the diameter of the nichrome wire. So the nichrome wire we are using is 0.29 millimeters. That is the thickness of the nichrome wire we are using. We can replace the values. Resistance is 16 is equal to, we have the resistivity times length. Length is, we are working with 1 meter, so 1 meter, then divided by cross-sectional area. Cross-sectional area of the nichrome wire. So the cross-sectional area will be given by pi r squared. So the cross-sectional area will be given by pi r squared, and that means it will be 22 divided by 7 times. If diameter is 0.29, then radius will be 0.29 divided by 2, which is 0.145, then times, because this one will be millimeters squared, so it will be times 10 raised to negative 6, because we are converting millimeters squared into meter squared. That is 10 raised to negative 6. So let's see now. So resistivity will be, we have 16 times pi times 0.145 times 10 raised to power negative 6, and this gives us 7.288 times 10 raised to negative 6. Then we also need to know what is the value of the unit for this. So let's see, this one is in, let's work out the unit here. So 16 is ohm. Then we are multiplying by pi as no unit. This one is meter squared. Then we are divided by 1 is meter. 1 is meter. So meter squared means meter times meter. So that is ohm times meter divided by meter. And this gives us ohm meter. Ohm meter, because 1 meter will cancel out. 1 meter will cancel out. So we remain with ohm meter. And this becomes now the resistivity of the nichrome wire we have used. So that marks the end of today's session. I wish you the very best.